Welcome to this explainer. Today, we're basically acting as scientific detectives. We're going to uncover the massive, planet-sized clues, proving that all our continents were once locked together in a single supercontinent. We need to stop looking at Earth as this static, unchanging rock and start seeing it as a dynamic, living, and constantly moving puzzle.
So, think about this. What if the ground beneath your feet has been traveling for millions of years? It totally messes with what we see every day, right? I mean, you look out your window, the ground seems entirely still. Mountains look permanent, but if we could somehow hit fast forward on geological time, a radically different picture emerges. The continent we know today, they're actually on a very long, very slow road trip.
To solve this mystery using the claim evidence reasoning framework, we've broken our investigation down into 4 distinct parts. First, the supercontinent mystery, then fossils, rocks and mountains. Next up is glaciers and the seafloor, and finally, connecting the evidence. Let's get right into it.
Starting off with Section 1, the supercontinent mystery. This is the grand claim that literally kicked off this whole scientific investigation back in the early 20th century. Enter Alfred Wegener. He introduced this massive, mind-bending idea called continental drift, suggesting the solid ground is actually moving. Imagine trying to tell people in the early 1900s that entire continents were just drifting across the globe. Naturally, people thought it sounded absolutely crazy at the time. But he stuck to his guns, proposing that our land masses weren't just fixed in place, but had drifted apart over immense stretches of geological time.
And what's really fascinating here is the name he gave it, Pangaea. It literally translates from Greek roots to all Earth. It paints this incredible picture of one massive, united puzzle. Wegener suggested that if you rewind the clock far enough, every single continent we see today was fused into this one gigantic supercontinent. It completely turned the idea of a permanent, unmoving world totally upside down.
Now, I know it's super hard to wrap your head around deep time, but this timeline kind of helps us map out the journey. In the distant past, they were all assembled together in one mass. But roughly 200 million years ago, Pangaea gradually began breaking apart. And those huge fragments drifted incredibly slowly to get to the present-day arrangement we see on our maps right now.
Oh, and real quick, misconception alert. Before we look at the actual clues, let's play 2 truths and a lie, the lie being the continents move fast. Actually, scratch that. It's more like a painfully slow geological crawl. We are talking about movement happening over millions of years. It's happening at a speed roughly equal to how fast your fingernails grow. You'd literally never feel it happening, which is exactly why scientists had to rely on clues left behind in the rock record to prove it actually happened.
Moving on to Section 2, fossils, rocks, and mountains. Let's look at our first set of clues and see how biological and geological evidence acts just like fingerprints left at a crime scene. Take a look at this. We have fossils of the Mesosaurus, which is the small freshwater reptile, and they're found in both South America and Africa. This begs a very suspicious question. How on earth did a freshwater reptile cross the vast Atlantic Ocean? Look at a map today. There's thousands of miles of incredibly deep, treacherous, salty ocean separating those continents. A tiny freshwater reptile simply could not have swum across that. It's physically impossible.
Well, here's the kicker. It didn't. The land moved. Finding the exact same extinct species on continents separated by vast oceans is absolutely crucial biological evidence. It tells us that when that little Mesosaurus was alive, South America and Africa simply had to be connected as a single continuous landmass.
And this brilliantly illustrates why scientists needed more than just the jigsaw puzzle fit of the coastlines. Coastlines are constantly changing. They erode, sea levels rise and fall over time. So scientists needed permanent structural matches. They needed ancient, deeply rooted rock cores known as cratons to really prove the claim. When you look deep at these cratons, you see this locked-in, continuous pattern of the exact same age and type of rock stretching across separate continents when you fit them back together.
Imagine sliding all these landmasses back together. These matching ancient mountain belts form a perfect, continuous, linear feature right across the globe. We're talking about fragments of the exact same old fold mountain belts scattered across Greenland, Canada, Ireland, Great Britain, and Scandinavia. This tectonic fit acts just like a sentence printed across a torn piece of paper. You line up the tear, and boom, the sentence suddenly makes perfect sense again.
Okay, Section 3, glaciers and the seafloor. Our investigation now brings us to some seemingly out-of-place climates and, honestly, the ultimate smoking gun found at the bottom of the ocean. Finding ancient glacial deposits in tropical regions today is just mind-blowing. That is, until you realize those landmasses used to be clustered together, freezing down near the South Pole. Today, places like Africa and India are obviously quite warm, but the rock record definitively shows they were once covered by ancient massive ice sheets. The only way this climate evidence makes any sense at all is if these continents were situated way further south back when they were part of Pangaea.
Now here's the thing, Wegener didn't actually know how the continents moved, which was a pretty massive problem for his theory. But later on, this physical mechanism, seafloor spreading, provided the missing puzzle piece. It explains exactly how ocean basins open up and push continents aside. Material from below rises at mid-ocean ridges, new oceanic crust is actively formed, and the seafloor moves apart in both directions. It acts almost like a giant geological conveyor belt.
And it gets better. These magnetic stripes are basically Mother Nature's barcode. They provide a clear record of the creation and outward movement of this new crust over millions of years. See, as magma rises and cools, the magnetic minerals inside lock in the direction of Earth's magnetic field. And because the Earth's magnetic poles occasionally flip, we get these perfectly matching repeated bands on opposite sides of the mid-ocean ridges. This absolutely confirms that the seafloor is indeed spreading.
Which brings us to Section 4, Connecting the Evidence. It is time for the final verdict, where we synthesize all these puzzle pieces and see if our original supercontinent claim actually holds up.
You know, a single matching shape, sure, that might be a coincidence. But when all these independent lines of evidence agree perfectly, you have an airtight scientific case. We've got biological evidence from identical extinct fossils. We've got geological evidence from continuous ancient rock cratons and matching fold mountain belts. We've got climate evidence from misplaced glacial deposits. And finally, seafloor spreading and magnetic striping. They all independently point to the exact same conclusion. Our present continents were absolutely connected.
And this synthesis shows us exactly how scientific reasoning works. We don't just rely on appearances. We build a rock-solid case from diverse, converging data. Using that claim evidence reasoning model, the claim that continents move is strongly backed by undeniable observations, and the reasoning connects the dots, explaining why those observations validate the supercontinent model. It takes what was once considered a wild idea and turns it into established science.
So this mountain of evidence didn't just prove Wegener right. It beautifully evolved into the modern theory of plate tectonics. This broader theory tells us that Earth's outer shell is broken into these massive, puzzle-like lithospheric plates that constantly shift. It's a dynamic system we can actively map today through earthquake and volcanic activity in places like the Philippines, for example. It explains how Pangaea broke apart, sure, but it also shows us exactly why our planet is still geologically active today.
But here's the crazy part as we wrap up this explainer. The puzzle isn't finished. Earth is still a dynamic, moving machine. The seafloor is still spreading, the plates are still shifting, which really leaves us to wonder, where exactly will the continents be in another 200 million years? It kind of makes you look at the ground beneath your feet in an entirely different way, doesn't it?